Okay. First, I guess let's start with some of the semantics. So you guys recognize that you have an exam that's going to be due next Wednesday?
Yes.
Okay, are you guys ready?
No.
No. What do you mean by no? You've been studying, right? The whole weekend. Gave you guys some extra days in there.
I had cocktail hour the whole weekend. Sorry.
And he's like, it was no chemistry going on at that time, was it? Yeah. So how was your break? Are you guys revitalized and ready to go? Yeah. Are you guys struggling with the 7 o'clock hour?
Yes.
Yes. I want to change so bad. At least an hour.
Maybe we all can change.
Yeah. Yeah. Yeah, that would be a good idea. Or does 7 o'clock work for everybody?
Like sometimes it does and sometimes it doesn't.
It doesn't? Yeah. You guys would be okay for like an hour ahead in the future.
Yeah.
I know, I'm struggling. By the time 7 o'clock hits, I'm like, okay, let me go get something to eat, revitalize myself, then I want to go to sleep immediately because exactly. So
The weather don't
I know. It's been real cold. Because then you want to cuddle up. Yeah. Okay, so you guys also know that tonight you have your lab reports that are due. Right? Tonight, your formal lab reports are due. It'll take you an hour and a half to write it up if you follow the instructions, you know.
Hope you have your videos on ×2.
What was that?
Hope you have your videos on ×2.
Times 2, yeah, you know.
The videos are like an hour, 18 minutes. Both of them.
But you'll get it done.
Yeah. I was watching Grease and it took me all of Grease to finish it.
Multitasking.
The first movie or the second movie? The first one. The one that's on Netflix. Oh yeah, it's just the first one. Don't have the second one.
I have a question. Do you give us like paper, like this paper to put on the data of the mental? Or we did it on our
You
own
did
notes?
you did it on your own notes, and
Okay,
then
yeah, because I have seen the video and I'm like, wait. he
Oh
didn't
shoot,
give
that's
us
what I
that
forgot to
paper?
add.
Wait, what?
oh, actually no, I did give you guys a handout with it, and that you guys could write the data in. Yes, I did give you that initially. So remember, one person in your group probably wrote down the data and shared it with them.
And then now it's recording.
Okay. Let's
Thank
see.
you.
So there's a question. So will there be a review for the test? So there will be a couple of reviews that'll be going on. I will be talking to the TAs to confirm their times. I will give you their times and their links to make sure that you guys will have access to the review. I will do a review. One review. It'll be happening during my cocktail hour on Sunday. So we'll have drinks and we'll talk shop at that point. So Sunday from 6 to 8. Okay. So any other questions? Other questions? Good. Okay, so let's see. So today we're going to be talking about the atomic theory. We've kind of already talked about it. You guys have already done labs on it. Some of you guys have. My Harnell class, you guys haven't done it yet. But we're going to kind of start with that.
I got a question.
I may have an answer.
All right, so for
Be
the
good.
mental lab or the Excel, the data thing, do we have to have Fireball sign or just the?
No, you need everybody's side because you have Fireball, you have Kalinga, and you have Salinas. So if you go to the link, right, the link that I initially sent you, you should have access to everybody's data. Everybody's data is there. And if you watch the video, it'll take you how to do it, show you how to do it.
I was doing that, but I didn't, that's like,
And
it's like.
any other questions? No other questions? Good. Okay, so we're gonna start with Dalton's atomic theory. So Dalton was a scientist, and he basically came up with this theory about the atoms itself. He said that each element is made up of particles that are called atoms. Atoms are going to be indivisible. You guys know what I mean by indivisible? They can't be broken apart. They can't be divided. They can't be, individualized, broken up any further. Okay. Then he said all atoms of an element are identical in respects, in every respect. So in every way, they're exactly the same. Okay. Then he said atoms of one element are different than atoms of another element. And the last thing he said was atoms of one element combined with atoms of another element form a chemical compound. Okay. So knowing what you guys know at this point, are you guys in agreement with it? Yep. With every aspect, huh? Okay. Anybody else?
This one. My mistake.
No. That's all right.
It's all right.
Yeah, it is. I needed it for this slide today. Yeah, I figured it out. What's that here? Fireball?
I was in firework, but then we'll be here on the way.
Oh, okay.
So we don't fight over the printer.
Okay. Okay, so, yeah, no, maybe.
Aren't they trying to split one right now? Or in that like big old tube thing?
Yeah, so we do split atoms.
Okay.
Yeah.
Okay,
So then you said they are indivisible, right? So atoms can be broken up into smaller components, right? And that's the one of a couple of things to be different. So we're going to talk about that, okay? Doesn't it feel like a Monday?
yeah.
It feels like a Monday, doesn't it? So this is just a depiction of exactly the same thing that we just said. If you take a look in the very first panel, it says all atoms are identical. So, in the second panel, where the hammer's at, that says that atoms can be created or destroyed. Can't be created or destroyed, but we can split it, right? And that's what you're kind of making the implication. We'll be talking about splitting those atoms, right? And then it says atoms of a given element have same properties, including mass. And atoms of different elements have different masses. And then the last one is that atoms of different elements can be combined in ratios of small, whole numbers to form chemical compounds. Okay, so one of the laws that we're going to be talking about is the law of multiple proportions. Law of multiple proportions basically says that if we have two elements, they can be combined to form a compound. Now, different weights of one element that are combined with the same weights of another element can have ratios of whole numbers. So for instance, if I have carbon and oxygen, together they form carbon monoxide. It has one carbon and has one oxygen. Now, if I have one carbon and 2 oxygen, that's going to form a different compound called carbon dioxide. They're different, although they're made up of both the same type of elements. They're going to have different weights that are going to be associated. They're going to have different quantities of oxygen that are going to be associated with it. They're going to have different characteristics, different properties. Okay, pretty simple. So if I look at the element as, or the compound as a molecule, a single molecule, or whether I look at it as a whole bunch of molecules, those ratios are going to be the same. So the ratio of carbon to oxygen is always going to be the same. So in the case of carbon monoxide, it's always going to be a 1-to-1 ratio. In the case of carbon dioxide, it's always going to be a 1-to-2 ratio. Straightforward, right? Good. So now subatomic particles. So Dalton said that things were indivisible. Well, we know that that's not true because we have subatomic particles. So are you guys familiar with subatomic particles? It's a Monday in your guys' head. I need some energy now. Subatomic particles. You're not familiar? Okay. So let me familiarize you with them. There are 3 subatomic particles. One of them is called the electron. The electron is going to have a negative charge associated with it. Okay, so we often will use the symbol 1 negative to represent a negative charge, right? Or if there's 2 negative charge, it means -2. That means you lost 2 electrons. But if you have 1 electron, it's always going to have a 1 negative. Okay. The symbol that we use for an electron is going to be E-. Okay. And I can tell you the history of the electron and how it was formed, but basically credit is given to J.J. Thomson for finding it. Okay. The other subatomic particle is a proton. Protons are positively charged. Symbol for a proton is just going to be P plus. And the last subatomic particle is a neutron. And that's going to be neutral. Okay. So electrons are going to be negative, protons are going to be positive, and neutrons are going to be neutral. Symbol for a neutron is NO, and not 0 there. Okay. Now, so initially when the protons and neutrons were initially figured out, they were trying to figure out the organization of how it is in an atom. So we know that an atom is composed of 3 subatomic particles, protons, neutrons, and electrons. The next thing that they were trying to figure out was how it was organized, okay? And actually, they didn't know about the neutrons at that time. So what they did, they had a model. It was called the plum pudding model. So plum pudding is like a bread pudding, and it has raisins in it, okay? So, but in that case of the raisins, they had, the raisin would represent a plus, and then kind of the dough area would represent minuses. So you had pluses and minuses throughout the entire thing, right? And so that's the initial model that they believed it to be. But they found out that that wasn't the case. That wasn't what was actually happening. But they started off with that hypothesis. So what they did to actually prove that that wasn't the case, Rutherford basically took a gold foil, a really thin piece of foil, a thin piece of gold, and then shot it with positively charged particles. These are called alpha particles, okay? Now these alpha particles, as they were flowing through the foil, at certain points, they noticed that they would deflect off of it. At other points that they would go through. But this deflection and how they were deflecting, right, led to a pattern, right? So they noticed a pattern that was going on. Now, if it was that bread pudding model, which was totally random, you had pluses and minuses randomly scattered through a surface, right, or a gelatin or something like that, then you would have a very random pattern, right? It'd be totally random. There wouldn't be any pattern associated with it. You'd have stuff all over the place if that was the case. But you saw a very defined pattern where things actually shut through and other things deflected off, right? So that's suggested because we know that if we have two positive particles coming together, what happens? It repels. So in the case of two positive particles coming together, they saw a deflection. So they saw some deflection. But in the case of negative particles or empty space, those alpha particles were able to flow through or to be trapped. Okay, so we had deflection and then we had that flow through. So this told us that there was some organization to the atom itself, right? That there was a nucleus, right? And what they found out is that within the nucleus, we have our protons. That's where all of our positive charges are. On the outside are the electrons. The electrons are orbiting, kind of like the Earth orbiting the sun. So they came up with the new model. They said, well, we have the nucleus. That's where the protons and the neutrons are going to be located at. That's also where going to be the most of your mass is going to be located at. Protons and neutrons make up the mass of the atom. The electron is so small, although it has a charge, a strong charge associated with it, but it's so small that it doesn't affect the weight of the atom, or it minimally affects the weight of the atom. Okay, it's kind of like, so I weigh 220. If I put a speck of dust on my shoulder, then is that going to affect my weight? No, not on my scale, right? Still going to weigh the same. Okay, so in that context, we know that that dust doesn't play a part in my weight, right? My body does, right? And that's it. So in the case of the atom, the protons and the neutron make up the weight of the atom. Okay. Okay, so this is how the atom is expected to look, right? We have the nucleus in the center there, right? And then this here represents what we call the electron cloud. So the electrons are basically orbiting around the nucleus, moving around the nucleus, okay? So here, this here is the nucleus itself. So if we kind of put it in perspective, this is the atom, this is the nucleus, right? So we put it in perspective. If you had a blueberry in the center of a football field, right? Now that blueberry is going to represent the nucleus, and then the atom is going to be the football stadium. So that kind of gives you an idea of how big the overall atom is compared to the nucleus itself. Okay, and so all of that space, right, between the nucleus, a lot of it is empty space. It's just the electron moving throughout that space. So that electron is orbiting around it, or the electrons are all orbiting around, depending on where you're at. Does that make sense? Give or take? It's a rough day, man. It really feels like a Monday. You guys are like hardcore. Okay, so let's reflect. So who's positive? Protons. Who's negative? Electron. Who's neutral? Where are protons located? In the nucleus. Where are neutrons located? The center, the nucleus. Okay. And electrons are located where?
Space.
Empty space on the outside. That's right. Okay. So now we know, just from our personal experiences and everything like that, if we have two positives, what's going to happen? They're going to what? They're not going to attract. They're going to repel, right? They want to get away from each other, right? If we have two negative, what's going to happen? Same thing. So we need that positive and that negative to kind of hold everything together, right? For that attraction. Okay, so that's going to be important. That's important for us to understand. Okay, that positive and negative, those electrostatic forces, are what's going to be kind of holding that atom together. Okay, and we're going to talk about that. That's going to play a part in the radius size. That's going to play a part in how the atom is going to be organized. All of those things. Okay. So we already talked about these guys, right? So Rutherford was responsible for determining or discovering the proton, and Chadwick was responsible for discovering the neutron. So the mass of the proton and the mass of the neutron are approximately the same. They're like very, 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 very close. They're a little off, very close. So we kind of give them the value of 1. Each one has a value of 1 associated. Okay. That's the best thing about science. When you first discover it, you can do some crazy stuff, right? Okay, so we know that the electron is significantly smaller. It's actually 1,837 times smaller than the proton. Okay, so it's tiny and light. But it packs a hell of a charge. Okay. Isotopes. Iso meaning same. So it basically means same. So basically it has the same atom, right? So your atom is exactly the same. The only thing that's different about it is the mass. Okay, so let me give you an example. And you guys have already gone over this. We've gone over in lab. This Kalinga has. Carbon 12 and carbon 13. So this upper number so that represents the mass. Okay, so that would be the mass of our isotope. We call this the mass number. Symbol that we typically use is A. This number here this is the atomic number. Symbol we use is Z, and that's going to be the number of protons. So the mass number is going to equal the atomic number plus the number of neutrons. Okay. So if we look at these two, they're exactly the same element. They're both carbon, because the atomic number is used to define the element. Repeat that. The atomic number is used to define the element. So the number of protons let us know what element we're talking about. Okay. The mass number lets us know how much that isotope weighs. Okay. So if we have carbon 12, very first carbon, carbon 12, how many neutrons does it have? Six. We're just solving for n in this case, right? So we have 12 minus 6 is going to equal 6. Okay. The second one. Well, I'm not the only one that turned up this weekend. You guys are struggling here. 7. So we have 13 minus 6. That's going to equal 7. Okay. So we're able to determine the number of protons. Number of neutrons. Okay. So we're able to sit there and tell you how many protons, how many neutrons that we have in our atom, right? How do we determine the number of protons? Of electrons. So every atom on the periodic table is neutrally charged. It has a total charge of 0. Okay. So if we have 6 protons, how many electrons must I have? 6.
They're the same.
So it has to balance out to equal 0. Okay, simple, right? Okay, so we're going to test your skills. Okay, so let's go to the periodic table. You guys are very enthusiastic today. Niobium. Niobium. So if you guys can do me a favor, find it on the periodic table. So that top number this number here represents the atomic number. Okay. This number here represents the average atomic mass. So almost every atom has isotopes associated. So in the real world, we have, let's say in the real world, there are sometimes a couple of isotopes. And what you're getting there is the average of those isotopes. Okay, so if we're looking at the periodic table, we're looking at the average of a couple of different isotopes added together, right? Based upon the quantity that there are in nature, okay? So what we do is to determine its mass number, we're gonna take an estimate. So we're just gonna take the number, so it'll be a whole number, and we're gonna round it up, right? We've talked about that, right? Okay, so niobium, what would be the mass number for niobium? Are you sure? The mass number. Okay, so the mass number is 93. Okay, what is atomic number? Number of protons,
41.
right, 41. Number of neutrons,
41.
sure.
Wait, just kidding.
So it'll be 93 minus 41.
52.
Okay. Number of electrons, okay. Questions? No questions. Cash. Okay, so let's see. What element do we have in group 14, period 6? Give me the element, symbol, tell me the symbol. What's that? We have lead. Okay, so lead. Okay, so we have lead. Jerry. Just checking to see if you were reading the back of your eyelids or. Okay, lead. We're talking about lead, right? So, lead, what is the atomic number for lead?
82.
82. 82. How many protons does lead have? $82 for lead. Proton was 82. What about neutrons?
Is it 125? Would it be negative?
Would it be negative? Can you have negative neutrons?
Something?
Was that?
No.
So it's just going to be 125, right? Okay. What is the mass number? 207. Number of electrons?
82.
Okay. Questions? No questions? Any concerns? Okay, good. Okay, so now let's say we had an isotope of our lead that's on the periodic table. So we have PV, (210), (82). What is that? So what is changing in this case?
The mass number.
The mass numbers change. Okay, so we have a change in our mass number. So what is the mass number, the new mass number? what is the atomic mass? It's 210, right? So the mass number is just going to be the atomic mass for that isotope, okay? So it's going to be 210. Number of protons. Atomic numbers.
82.
82. Number of electrons.
82.
And number of neutrons.
128.
Okay. Simple. Okay, good. So now if I have an ion, what is an ion again?
Isn't it like one charge?
It's charge. Okay. So we've talked about chemistry. Chemistry is going to be because, okay, so if we think about our atom, right? In the atom, the nucleus is in the center. Where are the electrons located at again? The electrons.
And the nucleus.
They're empty space. Are they located in the nucleus? But you said in the empty space. Outside of the nucleus? Between the nucleus? Where are the electrons located? Where are electrons located?
Electron cloud.
In the electron cloud, where is that located at?
Outside.
Outside the nucleus. So the nucleus is in the middle, right? And then we have the electron cloud on the outside, right? Okay. So electrons are located in the electron cloud outside of the nucleus. Now, what's going to be easier to get to? The nucleus or the electron cloud?
Electron cloud.
Electron cloud. Okay. So chemistry is going to be based upon the movement of electrons. So a chemical reaction is going to be based upon electrons. So we've talked about this already. I'll talk about it again, and then maybe it'll start kind of clicking here in a minute. But if we think about it, either you're going to be giving electrons, you're going to be taking electrons, or you're going to be sharing electrons. Okay. So you're giving electrons, taking electrons, or sharing electrons. Okay. Now, why are we doing this? Why do we want to give, take, or share electrons? What is the purpose? What was that? But why would I want to make a compound? Can I ask you a question? I'll ask you a question before you answer that question. Like, slow down, right? So, why are you in this class? To learn chemistry.
To get rich. 'Cause we
Say it again. To get rich. Okay, so we're here to get rich, right? You're doing this to get a job, aren't you? Anybody here independently wealthy? Anyone? Okay, so we're all here because we want to get some stability in our lives, right? So the way that you get stability is either you take, you give, you share, right? So you can marry somebody who's rich, right? That's kind of sharing. You're sharing their money, right?
He's sharing.
He's sharing his money, right? Okay. You can take somebody's money, right? Or if you're a giver, you can give somebody money, right? Okay. So the reason that you're here is we're looking for stability. So if you guys remember, noble gases are kind of like those rich folks. Noble, right? They're rich. Okay. Now the noble gases, they're stable. They have the number of electrons that they want, that they need to be happy. All of the other elements on the periodic table don't. So they're trying to find ways to make themselves stable. And one way is to try to be like the noble gases. So primarily the elements that are in the main group, you guys remember which ones are the main group?
Is it the green ones?
So it's like 1, 2.
It's not the green ones. The green ones are they're non-metals, reacting non-metals.
Group A theater.
No, so those are diatomic elements.
We talk about this
Well,
yesterday, I wasn't there.
The
Group
main groups
18.
is 1 through 2 and 13 through 18.
Say it again.
1 through 2, 13 through 18.
Yeah, group 1 through 2, and then group 13 through 18 is the main groups. Okay, now the main groups all try to fill their outer shell, right? And the way that you're filling your outer shell is either by sharing electrons, taking electrons, or giving electrons. Okay, now when you're giving and taking electrons, that's the process of forming ions. So if you give an electron, you're giving up an electron, you're giving it away, that means that you're going to become positive. Okay, a positive ion is called a cation, right? You remember that? My bad joke? Because it's positive, right? Oh my gosh, I got 2 laughs this time. I'm doing better, man. Okay, now cations are typically, they're going to be metals, right? So they're going to be metals that are going to be giving up electrons to try to get some stability. So they're trying to get like the noble gases or trying to find a way of being somewhat stable. Transitional metals find their own special way of being stable. So we'll talk a little bit about those later on, right? They're special, right? Okay, but group 2 metals, those metals want to lose 2 electrons. So if you lose 2 electrons, right? Now remember, let's say, for instance, we're talking about magnesium. We'll give us a real example. So we have magnesium. Magnesium has how many electrons?
Well,
Normally. Okay. So normally it has 12 electrons. So we have 12 electrons. You mind if I use the symbol rather than typing it all out? You remember it? Okay. And then how many protons do I have?
12.
12. And how many neutrons do I have?
12.
So I can't see the number. So 12. Okay. Now, for it to be a noble gas, it has a couple of options. Okay. And I want you guys to think about this in your life, right? Say you've been working all day, you know, working really hard all day, and you want to go and get a beer. The car broke down, but you really want that beer or coffee, you know, or beer in your coffee. Well, maybe whiskey in your coffee, but not beer. Okay. So now, if you're magnesium, you have 2 options to be like a noble gas. We know that the noble gases are located here, group 18. Okay, so you could either try to gain 1, 2, 3, 4, 5, 6 electrons, or you can lose 1, 2 electrons. Okay, so if you think about it in terms of your life, you walk in blocks. You can walk 2 blocks, or you can walk 6 blocks. Which one are you going to do?
2 blocks.
2 blocks.
Wanna lose
Right?
weight or what's this?
You don't want to lose weight. You just got off from work, right? You're not thinking about weight. You're thinking about that beer, right? Or that whiskey, you know? So in that case, you're going to use the least amount of energy. And so magnesium is going to go the easiest way because it's all about energy. We want to use the least amount of energy to find stability, right? If you have to use a lot of energy to get stability, right, then it's not worth it, right? Where you can do it a lot easier. Okay, does that make sense? Okay, so in this case, we're losing 2 electrons. So now, instead of having 12 electrons, we have 10 electrons. Okay, so our electrons and protons are no longer balanced. So what is going to be the overall charge on magnesium? Electron charge.
Is it 14?
Nope, the overall charge.
Oh.
So if I have 10 that are negative, and then I have 12 that are positive, so what is going to be my overall charge?
Two.
2 positive. So we write the ion for magnesium as 2 plus. So by seeing that it says 2 plus, that means it's lost 2 electrons. Okay. Let's say we're nitrogen. Here's nitrogen. Now nitrogen, also like magnesium, wants to find stability, right? So it's going to want to try to get electrons. How many electrons does nitrogen need to be like neon? Or it could try to be like helium. Which one's easier? Is it going to need 6 electrons? So we're right here, right? Count over. There's 1, 2, 3. 3, right? So nitrogen is here at 7, 1, 2, 3. To be like neon at 10. Okay, so in this case, nitrogen has a total charge of what? If it forms this ion. So
4?
3,
Oh, 3. Sorry.
right? So it needed to gain 3 electrons. So it's 3 minus. Because each electron has what charge associated with it? Electron?
No, negative.
Negative. So an electron has a negative charge associated with it, right? So since each electron has a negative charge, we have 3 electrons. We put 3 minus to tell us that there's 3 electrons added onto it. Okay? You see how that works? Are you sure?
Yes.
Okay, so we're gonna test this out. Yes, ma'am.
So like, let's say this was on the exam. How would it be worded?
What electron? If I add 3 electrons to nitrogen, what would be its symbol?
What would be its symbol if you added
3 electrons.
Okay. And we would have to look at the chart and be like. All right, like you would change what it is then.
Does it change? Does it change what it is? Is it still nitrogen?
Yes.
Yeah.
So the only thing that is that it's an ion instead of an atom. Okay. So because an atom, if it's an atom, the electrons and the protons are balanced. An ion has more electrons or less electrons. Okay.
Okay, ion and.
Yes. So, well, yes, sort of. Okay. So let me elaborate. Okay. So the atom is always going to be defined by the proton, right? So that tells me what atom I'm talking about. So I'm talking about nitrogen. So that means that my number of protons is always going to be 7. Okay. If I'm talking about calcium, my number of protons are always going to be 20, right? But if I'm talking about the calcium ion, right, I call it the calcium ion. Where if I'm talking about calcium, I can just call it calcium, or I can call it the calcium atom, or the calcium element, right? And so by me saying that it's an ion, lets me know that there's charge associated with it. Okay.
Either you lost
Or gain. That's right. That's right. If it's a metal, we know that they're going to be losing. Okay. Okay. If it's a non-metal, they're going to be gaining electrons. So if you gain an electron, you're going to be a negative charge. So then you're going to be an anion. So nitrogen, this nitrogen is the nitrogen anion. Okay. Got it? Okay, so we're gonna test this out, since you guys are professionals now, right? Because you told me you got it, okay? And I'm feeling that you got it. But we gotta be sure, right? Okay. Man, you guys are rough today. What you guys drinking yesterday? That's what it was. Y'all got mixed up on cocktail hour, right? Y'all thought it was yesterday instead of Sunday, huh? Okay. So let's say we have okay. Let's say we have this ionic isotope. Okay. So okay, how many protons does it have? Oh, what is it? Its atomic number. 15. Can you see? Or is my head blocked yet? I can't help it. I got a big head, you know. Okay. And then how many electrons do we have? Okay, so I heard 15, I heard 33. Anybody else want to put in their hat?
18,
18. So why is it 18?
because there's 3 negative, so that's putting electrons.
Okay, so since there's a 3 negative, that means that we're adding 3 negative charges. So that's 3 additional electrons. That'll be a total of 18. Okay, how many neutrons do we have? $33 minus 15. That's right. 33 minus 15. Which is?
18.
What is its mass number? 33. Okay. And the atomic mass?
33.
Okay, 33. Okay, now, is this an ion, an isotope, or both? Or an atom?
Which thing?
I said, is it an ion, isotope, or both, or an atom? Both? Both? An ion and an isotope. Okay. Piece of cake?
Yes.
Okay, so let's see if we can do one. We'll do one of those transitional metals that I told you that be kind of funky. Guys ready?
Yes.
Okay. Okay, so now let's do
76.
Yes, 76. Okay, so what I want you guys to tell me, list down. Bonds. Neutrons. Protons. Mass number. Atomic mass. Electrons. Atomic number. Tell me if it's an isotope, ion,
So, you know.
Yeah.
There's 56 neutrons, the atomic number is 76, atomic mass is 20. There's 82 protons and 76 electrons.
you said 56 neutrons?
Yes. Yes.
Neutrons, 125.
Okay. So 125. How did you get 125?
Oh, I didn't see the one.
201. Okay.
I
Just
think I
kidding.
should guess 201 minus 76.
201 minus
Supposed to be.
76.
You read it wrong.
I didn't see the one,
Okay.
but I'm pretty sure that the protons are there.
Yeah, and it always is going to be greater than. Okay, so 201 minus 76. Okay, protons, you said was what again?
82.
Proton was 82?
No, oh my gosh. Never mind.
76. Okay,
Oh, okay.
so 76 protons. What is the mass number? One. Now, the atomic mass. What did you say? Oh, there we go. Atomic mass. So we have 70.
2.
Atomic mass is going to be the same as the mass number, 201. Number of electrons.
Is this what
Oh,
82?
somebody, yes, somebody said that. 70. 70
Oh, okay.
electrons. Okay. The atomic number,
76.
76. Is it an isotope?
Yes.
Is it an ion?
Yes. Okay, I have a question.
Yes.
So whenever there's nothing like adds to the protons or anything, so what I thought was it's a plus, so I thought it added to the protons. But it just takes away from the electrons if
That's
it's a
right.
plus, and then if it's
Yeah.
minus, it adds to because it's negative, right?
That's right.
Okay,
Yes.
got it.
So in chemistry, when we're doing regular chemical reactions, the only thing that's going to be changing are going to be your electrons. Your electrons, either they're going to be shared, they're going to be taken or given. Okay. So you're gonna be taking away or adding to it, okay? So you're never gonna be affecting the protons in a chemical reaction. Now I'm stressing this because in a chemical reaction, that's what happens. In a nuclear reaction, it's gonna be different. Okay? How you guys doing? Okay? Isn't it cold outside? It's very cold.
It's gonna be colder tomorrow.
Okay, are you feeling confident? We're gonna do one more for the road.
How do we get the 70 again for the electrons? What do we have to subtract or?
Okay, that's a good question. So the question is, how do we get the 70 for the electrons? So we take a look at our number. This tells us that we have 6 plus, right? So that means that the overall charge is 6 plus, which means that we've lost how many electrons? 6. That's right.
6. Oh, that's right. It's the opposite.
That's right. Yeah. Okay. So you want another challenging one?
Okay.
Excellent. I'm glad that you said yes.
Okay.
See, that's what you get for not talking, right?
I
Uh-huh.
was gonna
Teach
ask
ya.
a question.
Yes.
I was gonna say if that's
anything.
what
That's what he
this is,
said.
yes, moved on.
That was the case. He's looked down and said, I just said yes. I didn't say anything. I know. I won't keep guessing.
Is that PU?
Both of y'all talking. You say yes? Didn't say a word.
I see that.
That's plus one. Okay.
That's a 241
That's
plus
241, yes. Yeah, PU.
Any makes a difference when you shrink it plus first.
So actually, you're right, you're right. Plus 4. There. Yeah,
Does
4.
it make a difference?
It does, well, it's, some textbooks will put it in front. And some textbooks will put it in back. So normally you put it in the back, that's what you're supposed to do. It's been a long day.
Okay, now I just got confident.
Confidently.
Protons, oh wait, can I say it?
Give everybody a chance.
Okay, just kidding. I will wait.
She's excited, she's like, my wheelhouse.
No, oh my gosh.
I got one.
She's like, you're very excited. I just gotta do something.
What?
Dr. Henry? I have a question. How do you know when something's an isotope and an ion again?
Okay, so if it's an
Yeah,
isotope,
that wasn't clear with me either.
okay. So when it's an isotope, your mass number, anything that has a mass number associated that's written there is considered to be an isotope. Okay, so anytime that you have a number that's written there, it's an isotope. Okay, and then if you have a number, you guys see where I circled? I'll circle this one in a different color. I'll put it a box. So the one that's in a box if there's a charge, right? So this is 4 plus, so that means it's an ion. Does that make sense?
Yes.
If it was a negative, would it be an ion as well?
Yes, but it would be an anion instead of a cation, but they're both considered ions.
In the test, are you gonna ask if something's a cation or a anon?
It's all fair game, yes. That was my question. I was gonna get to that. Okay, are you guys ready? Ready for redemption?
Yes.
Okay, so we'll let you start off with the first one. Protons,
94.
94.
Oh, just the word.
Yeah. Okay, let's see. Jerry, number of neutrons. How did you get it?
Honest. This is honest.
Okay, explain to me what you see off that paper.
I see the mass.
Okay, the mass number minus. So which is 241 minus 94, which is the number of protons. That's right. Let's see. Alexis,
Yes.
number of electrons.
90.
How did you get that?
So you have 94, and then you have, which are negative, right?
That's right.
And then you add the 4 to the negative, so it's 90.
Okay, perfect. Okay, let's see.
Or
241. Okay. Are you sure for the atomic number?
Number?
Atomic number,
Oh, no, it's 94.
94.
The mass number
The
is
mass number is
241.
241. Okay. Is it an isotope?
Yes.
Yes. Is it an ion?
Yes.
Is it a cation?
Yes.
Is it an anion?
It's an anion because it's positive.
It's not an anion, it's a
Oh,
cation.
I'm sorry. I don't. Yeah, I had it mixed.
An anion is negative, right? So it's no. No, okay? Are you good?
So if, in case, let's say that if instead of 4 plus, it's 4 negative, then will be an anion.
That is correct. Yep. Here, let me give you an example, right? That'll be good, right? One example. Yes, we'll do.
Is it?
Okay. Okay, we'll start off with electrons. Protons. Neutrons.
Okay, let's go. Your pronoun.
Mass. Atomic number. Mass number. Okay. Ready?
Yeah.
Okay. Start us off with the
Electrons is, wait, hold up. Oh, damn. Okay, wait. Electrons is 54.
okay. How did you get 54?
I added the 3 negative to the bottom atomic number.
Okay, so we added the 3 negative to the atomic number. Okay. Number of protons. Someone else.
Oh.
Any volunteer or do I have to volunteer? Is it 51? Okay. Good, good. Number of neutrons. And how did you get that? Okay. Atomic mass. Atomic number.
Oh,
51. Mass number. 124. Ion.
You're so good.
Yes.
French fry.
You should make
Isotope.
Yeah. He's tired too.
I am. I've been up since 4 this morning, so.
Oh, does that mean that we get to actually? Yeah, I'm not even try.
No.
Cat ion.
No.
It's not.
It's not.
Oh,
Yes.
Anion, yes. Okay.
Oh, because
Yes, you got it.
yeah.
She's like, yeah.
Dr. Henry, I have a question.
Yes.
The atomic mass and the mass number are basically the same thing, or will they ever, or will they differentiate between each other?
So they're going to be basically the same thing. Only thing, the mass, the atomic mass can be a decimal form if we're looking at the periodic table, because then
Oh,
it's the average of all of the isotopes. We're not talking about a specific isotope.
oh, I see. And the mass is the rounded down.
Yeah.
Oh,
So
I got you.
that's right. The mass number is rounded. Yeah. Okay. Okay, so let's go.
I'm gonna fight you for real now. What are your words? Order.
Okay, so now you guys are familiar with isotopes, you're familiar with ions, okay? Now, a couple of things that I want you guys to know. I just showed you how to write the isotope. So this is just reinforcing that. So again, the mass number's on top, the atomic number's down here, and then that's going to be our symbol. Okay. Now, when we make reference to an isotope, we'll call it oxygen 16. So then that's the isotope that weighs 16 for oxygen. Okay. So carbon 13. Okay. Now that you guys are skilled, I want you to not look at your paper and fill out the table.
Gotcha.
Yeah.
Why you got him to stop? How do you figure it out? Without looking at.
Yeah, the bonds lot. We can look at that. Oh.
I cannot. I cannot.
The highest will be 49 tomorrow.
Not like super hot, like
Is someone space up in here? Oh my gosh.
all of a sudden, when he's in the little corner, he's on there. My house wouldn't fall. Look, it's so spacious. She looked too. You know, you were around what high school. You would call that. Oh, yeah. Yeah, it's like.
At the back, because I was they didn't do a lot of stuff. Just has letting cost now.
Okay. That's right, show me those skills. Yes. Okay. I will see you later. Yep. Okay. Ready? Sure. Okay, so barium, what is the symbol for barium?
Capital B, lowercase a.
Capital B, lowercase a. Okay. The atomic number for barium.
56.
Number of protons.
56.
Number of neutrons.
82.
Mass number. And then how would we write the name? Barium 138, that's right.
Yeah.
Okay, now this oxygen. Symbol for oxygen?
Oh.
Atomic mass for oxygen. I mean, atomic number for oxygen.
8.
Stop feeling like make that joke, okay?
Number of protons. Mass number.
60.
That's what I got.
Are you sure?
That's on the
This is 15.999. So wouldn't you, does it mean constantly round it to?
No, but you're supposed to use what you have on this paper. So
Okay,
how would I
so
calculate
18.
the mass number?
10 plus 8.
18. Yep. Okay, because here we have 10
Oh.
neutrons, right? Okay, and the nuclear symbol,
No, you get it. Yeah.
nuclear symbol,
Oh, 18. Oh, the oxygen. And then 18 on top.
Okay.
And then 8 will be on the bottom.
and we're gonna call this guy
Oxygen.
oxygen 8. That's right.
That is your,
It's like
your elemental symbol with the mass number.
So what would be the element?
that's gonna be like
Yes.
How did you figure that out?
The atomic number.
The symbol, oh, sorry.
Yeah, I'm like, okay,
Great.
well,
Well,
It's
it's
PB.
late.
okay. The number of protons. 82.
82.
Number of neutrons.
124.
Number of electrons. 82. Yeah, okay. The nuclear symbol.
Will
P.
PB.
206. Is it?
Superscript.
Yeah.
206. 82 subscript. Pre-subscript. Right before. Okay, and we call this okay. Okay, question? Yes. Was there a question?
Yeah, for lead.
Yeah,
So the neutrons is the oh, you're using the number that you're given for the mass number minus the proton.
that's right.
On the chart it says 207.2. If we were basing it off the chart, it would be 207 minus 82, right? Because we round down.
That's right. So you'd round it to the nearest whole number. So if
Okay.
it's greater than 5, you'd round up. If it's less than 5, you'd round down. Okay.
So why on barium, we did 138, if I'm looking at the periodic table and it's 137.33
Because we're talking about what's given to us on the chart.
on this chart, not on the periodic table. Got it.
So you want to make sure that you're looking at what's given to you on the chart, because that's going to give you what you're looking for, what you need. Okay. And if nothing's given to you on the chart, then you're going to assume that, except for the element, then you're going to assume that it's the periodic table. Does that make sense?
Oh, okay. All right.
Okay, so here we're given lead 66. So what does that mean for us? I mean, not lead 66, zinc 66.
That means the name's almost gonna be zinc.
Okay, so it's zinc. Symbol for zinc. Atomic number.
30.
Number of protons.
30.
Number of neutrons.
36.
Mass number.
66.
Nuclear symbol.
Are you drawing it, like
Yeah,
pressing it and drawing it?
yeah, it is.
Be one of those those projectors that you can write on it, it'll be on there.
The
That would
smart
be
Like
ones?
they're like old ones, but like they work really good.
Yeah.
Yeah, you know what I'm talking about? Yeah, exactly that.
The smart boards, I think, right? Yeah.
We used to have those.
Really?
Well, sort of.
Oh, wait, are you talking about the ones that like, you write it on it with a marker and it like reflects?
That's like a projector thing.
Yeah. Oh, I like those, those are cool. I saw it in a movie.
Okay, Questions?
Sorry, me, it was a good.
No questions, concerns, cash, Kool-Aid?
You got the right bread.
What is it called?
So these are just working with isotopes. So you need to be able to identify that. And it's gonna be, it's important that you get this down, particularly what we talked about with ions and knowing how many protons and electrons that you have, you know? Okay, so at the end of the day, we basically have shown that Dalton was incorrect about the atoms being exactly identical, right? Because we have isotopes. Okay. We also showed that there are subatomic particles, so it can be divisible, right? An atom can be divisible. Okay, so the atomic mass. So the atomic mass is going to be the average mass of the atoms of an element. Okay. Now, what we see on our periodic table is going to be that average. Okay. Now, when we talk about the atomic mass, our periodic table or the atomic mass, the mass value, is going to be based upon carbon 12, the isotope carbon 12. So carbon 12 is the most stable, abundant isotope. So our whole periodic table is kind of based upon that. So 12 grams of carbon, right, is the mass of 1 mole. You guys remember when we talked about the mole, right? Okay, so 12 grams of carbon is going to be 1 mole. And that's going to be what we define everything on our periodic table based upon. Okay. So when we talk about mass of, or our average atomic mass or our atomic mass on the periodic table, it's going to be based upon all of the isotopes that are in nature. So for instance, here we have 3 isotopes of neon. We have neon 20, we have neon 21, and we have neon 22. Now, while you guys are doing all those calculations, I've got an estimate for each of the values. So for neon 20, there is about 90.48%. For neon 21, there is 0.27%. And for neon 22, there is 9.25%. Okay, so for us to calculate the average atomic mass of all of the isotopes, what we're going to do is we're going to take this value here and then we're going to multiply it by the decimal form of our percentage. So that's going to be 0.9048. That's
You're trying really hard.
I am. I'm struggling today. It's just. Okay. So, and then we're going to do the same thing with each of the other isotopes.
You know, we're gonna round that, because it gave me 18.096.
Yeah.
Can I round it to 18.10?
For right now, we're going to have, so we're going to assume that this is an exact number, so that's 20. So then we're just going to use 4 sig figs, right?
Okay.
So for significant figures, that'll be 18.10. Okay, and then we have 21. So that's 0.0007. So in this case, we have 2 sig figs. So 5.7. And then we have 22 times 0.0925, 3 sig figs. Two point zero. Okay, then we're going to add them together. Okay, and you guys get any periodic table for neon? What is the value that you have for the atomic mass of neon?
Or 20.180.
21.180. Okay, so we got 20.187, right? Close enough. Give or take, you know. So then that would give us the average, right? Of all of the isotopes that are on there. So this is how they would calculate the average of the isotopes that are found in it. Okay. Straightforward? Yeah, no, maybe. Okay. So the way they actually do it is they take a mass spec. It's an instrument that actually charges the isotopes. And since it's all charged, the ones that are heavier are going to run a little bit faster, run a little bit slower than the ones that are lighter. So the heavier ones are going to be up higher, and then the ones that are a little bit lower, weigh a little less, are going to run a little bit faster. So they're able to quantitate how much actually goes through. Okay, so now here's an example for you guys to do. So we'll do the first one. We'll save the second one for you guys to do on your own time. Okay, and then we're going to take a break. I think we need a break. Okay, so it says the natural distribution of the isotopes of boron is 19.9%, boron 10 at a mass of 10.0012937 units, and 80.1% for boron 11 at 11.0093055 units. Calculate the atomic mass of boron.
Dr. Henry,
Yes.
for these type of problems, will the percentage always be given to us, or how do you find that?
Yeah, so typically they're gonna be given to you, or they'll be given to you in a table.
Got you. Where on the table would that number be? It would just be under percentage?
It'll say, yeah, so typically it'll say the element, it'll say the isotope for that element, and then it'll say percentage, yes.
Got you.
I'll show you an example of a table here in a minute. Okay, so you guys ready?
Yes.
Okay. So what am I gonna do?
Multiply 19.0%, 10.0129.
Okay, so I'm gonna change this to decimal form. So it's gonna be 0.199. We said multiply that times 10.012970. Three sig figs. Okay, and then
You do the same thing with the other.
okay, so 0.801 times 11 . 0.009 0.5. And three sig figs. Gonna do what?
Go ahead, page 20.
Probably because I screwed up the book.
Just double check.
0, 0.
Wait, no, you got it right.
Got it right?
Yeah.
Okay. So we add them together. a view. So what you got? That's a U for units. You'll also see AMU for atomic mass units. Those would be correct. Okay, questions? No questions. So, show you the table. Okay, so here's the table that I was making reference to. So you see how it's organized. You have the symbol, you have the mass, and then you have the percentage. So you may get a table like that where you have to do those calculations. Okay,
And it's just the percentage multiplied.
yes,
By the mass. Yeah, okay.
you have to change the percentage to fraction form or decimal form. So, divided by 100. So. Okay, and then you add all of them together. Okay, questions? No questions? So let's take a 10-minute break, and we'll come back, try to finish up as much as we can. Bathroom break.
I did have a question real quick. For the first symbol, which is hydrogen,
Yes.
on the mass, the 17.99, that's the atomic mass, and then the 18 is the mass number, right?
That's not for hydrogen. So they're in. So
Oh, I'm
yes,
sorry, oxygen.
mass.
Oxygen.
Yeah. Okay.
Sorry.
Yes.
Okay.
Does that help?
Yes, thank you.
What do you mean, like natural culture? Oh my God, but it's the process. For your journey.
Wow.
Journey is right there. My kid was wrestling my backpack, so her pulse started going. But my kids, so they go down and eat and they go back.
It really goes back.
Okay, so see, this isn't gonna help. Right? Yes. That cold.
At practice, we played a game called backward ball, and we had to do
Well,
everything.
that's
Like, so we had to wear in our left hand and throw with our, wait, we had to wear our left. Yeah, and then we had a bat, like, or not, yeah, whatever. And then we had to run around the bases like backwards, and we're supposed to run backwards, but she didn't want injury. And it was so funny.
Yeah.
Some of these girls are like, hey, good runs, and I was like, bro, that's not fair.
I needed to, I was on procrastinating because I knew it would take forever.
We can one.
Straight, I got you. Dude, I'm on tape, bro.
She usually backs up her too, so she's
I
like,
asked her for.
You rise up in my
Hey.
I think I'm not sure, it's so funny.
When I think there's a lot of things.
Yeah.
No. I was helping you and your friend.
Like, I tried.
And price is higher, bro.
Sorry,
There's gonna be a day when you're
We
gonna.
play, you know, backward balls? It's like, yeah, backward.
No, that's the other way around. I don't have fish. That's
So
why.
do I, but shit happens. I'm like, ah. So we had to ask.
I texted you on Cabbage when you answered.
That's
weird.
So funny. Like,
Over lag.
She hits you.
See that?
First of all, I don't even know
I
what
know.
I texted you on cameras when I gave you my fucking number. So yeah,
Did you really?
yes, I did, and her too.
It's
She's
so
on
funny.
here. Casting.
Did anyone catch them all?
Yeah.
Yeah.
Right here.
And then I'm like, oh, this comes.
Oh, that's
Second,
right.
it was not in, it was so good.
Hey, you should have came yesterday. I mean, did you?
And then I
I
caught it one time, like from a throw,
Yesterday they did, Tutors did,
and then the other throw I missed it.
Like,
Oh,
damn.
Okay,
But it was
but
fun.
fun.
Did you guys ever want to like
They were doing a.
play something?
It was 3 to like late.
Bad. You look creepy with the light hitting you.
It's
It's
so
like
funny. It was so hard.
the light is
So how much
shining
you
in
want,
your
Denise?
eyes. Hey, that's
I
a
like
lawyer
this
number
word.
one. I think that's the lawyer number. Yeah.
Okay, you guys ready?
Yeah.
Yeah, let's get this done, right?
Yes.
Okay, so we're gonna calculate the atomic mass of sulfur using the data on table 5. Calculate the atomic mass of sulfur using the data on table 5. So this chart is different isotopes.
Okay.
So if we're calculating the average of sulfur, the average atomic mass for sulfur, we're going to use these isotopes,
Oh,
all four of them. Yeah.
where did these numbers come from?
So they actually, like I said, they basically done mass spec on every element in the periodic table. And so when they do mass spec, they collect a sample from the earth or whatever, and then they run it through the mass spec. So the mass spec will separate it based upon its weight, and then it'll calculate how much of each of the different isotopes there are for each one. So,
And then they get the average and then put it
well,
on there.
so they took the average, yeah, they calculate the average, they put that on the table.
And so we're doing that here, just to
Exactly.
learn how they got it.
Exactly. So you appreciate the periodic table that much more. And sometimes what happens is that you may work with a particular isotope, right? Or need to isolate how much of an isotope that you're looking for. So you're going to try to get that particular one. So you may have to use the characteristics of that isotope to sit there and isolate. Not in this
That's
case.
like Chem 1, Chem 2.
We won't even do it here because there are reasons, but you know, we're not quite there yet. That'll be more like when we talk about physical chemistry, analytical chemistry. things to that extent.
In this course? In this
Not in this.
Okay.
We will be, you will be working with radioactive material. We're getting you to that point, but you need to understand isotopes. Some of the isotopes are going to be radioactive. So we'll be talking about that.
Like 3 weeks from now?
I'm gonna say probably 2.5 weeks.
There?
We're almost there.
Yeah. We're gonna have to be very careful.
We're almost to that point, yes.
Oh, I see, that's all like. I was like, I haven't given her to nobody, but you guys are the table story now. Okay. Yeah, but you said little hearts and I'm like this. So you went with that. I don't think.
Okay, so what are we gonna do? Okay, so what do we need to do?
You take the first atomic mass and multiply it by 0.9493.
Okay. So we end up with 30.35.
Correct. If you use it's 3 or 4 sig figs. How would you know again?
4 sig figs, because this one has a whole bunch and this one has 4.
Oh, correct. Okay.
Then the next number. 2 sig figs. So it's 0.5. Oh, John. Not allowed. We have 3 sig figs. 6.
If you forgot to like round up the 0.45 to 0.46, are you gonna get the wrong answer?
It won't be, it'll be close enough that it'll be okay,
Oh, okay.
but you wanna sit there and do it. If I catch that you're not taking sig figs into account, I usually deduct, like, I'll take a point off.
Okay.
The 10-point question, you know, that's a
So then
point.
after that, we still round it, so
What was that?
so after we round it first time, I got like 1.45,
Yeah.
so you beat 1.46.
Yeah,
So does that mean we should round it again or not?
no,
Okay, okay.
Why, second answer.
Yep.
You have 0.5.
where do I have? What, 0.25? Because it's 0.76. So then that's 1, 2, so then it's 0.0076 times this. Did I screw up on it?
I got 0.2505.
0.2505. Yeah, I got 0.2505.
Yeah.
So then that would be 2 sig figs, 2 significant figures, that means 0.25. Oh, I know it's from, show it, I share. So here, I change this, right? It's a fraction form, so that's what's there, right? So then I multiply it by this number, right? So I end up with this. No, you're missing 1 0. So. Because it's, yeah, you're missing, so yeah. You're missing a little bit. Because this number should. Point two, we're dividing it by 100. So if we divide this by 100, that'll be in decimal. Spots. So 0.
Oh, I get it, yeah.
No problem. Okay, what did you guys get? Same thing.
Yeah, I got the same thing. I got 32.066, but I didn't do the sig fig change on the 146.
But it should end up being 32.07, right? Because if we do the line, this is where I use this number here basically to round up. So
Right. Okay.
questions? Concerns? Is there a question? No question? Again. Can you see?
Yes, I do have a question.
Okay.
So we have 30.35 on the top, right? And so the other ones only have 3 significant figures. One underneath it and one below that. So would we want to like make 30.35 3 significant?
Because remember, it's addition at that point, right? So the first part, yeah, this part is 4 sig figs, right?
Oh.
Yeah. 4
Okay.
sig figs
What
here.
it started off with.
That's right. This one is 2 sig figs, right? This one here is 3 sig figs, 3 sig figs. This one only has 1 sig fig. So that's 1 sig fig, right? So then we add it together, we end up with the actual answer. This should be 32.067. But that's, we draw the line, this is where that line would go. So we use this number here to decide whether we're going to round up or leave it alone. It's greater than 5, so we're going to round up. So that's how we end up with 32.07 units. Did it look?
No, there's no questions here.
Okay.
Yeah.
Okay. Good. You guys ready to move forward? Got everything down? Okay. You already know, wait. Move forward. So you should expect to see at least one question on the exam. Okay. So if we look at the periodic table was actually very organized. Initially, it was based upon atomic mass, and then they realized that there are some anomalies, right? The arrangement wasn't perfect. And there were some errors with the atomic mass that was actually identified. So then what they started doing is doing it by the atomic number. So if you notice now, the periodic table is solely based upon the atomic number. So we've already talked about the difference between the main group and the main group and the non-main group, right? So you guys are already familiar with that, but this just kind of shows us what I was talking to you guys about. So this is an older periodic table. See, it was in 2009 that they did this organization of the periodic table, the way it is with the main group and non. So we, as scientists, we always go to IUPAC, the IUPAC nomenclature. So IUPAC is what we use. That's what all periodic tables are standardly based upon. You guys are already familiar, atomic number, symbol, and the mass. You guys already know about periods of groups. You already know about the main groups. You guys, can you identify the transitional metals on your periodic table? Yeah. How can you identify them on your periodic table? What do you guys have?
It's in color.
It's in color. It's color coded.
Oh,
right? And a letter in the corner. Yes, for those who are colorblind. Yes. There's a letter in the corner that also tells us something. So you're able to identify non-metals. We know we can identify the non-reactive metals from the reactive metals. I mean, the non-reactive metals and non-reactive. It's been a long day. Non-metal and non-metals that are reactive. So metalloids. So metalloids, they have both characteristics of metals and non-metals. And so sometimes they act like they're metals, and sometimes they act like they're non-metals. So sometimes they'll be a cation, sometimes they'll be an anion. It's going to be important for us to pay attention to who they're paired up with to make that decision. Okay. So list the atomic number, chemical symbol, the atomic mass of the third period element in group 6A/group 16. Okay, what is the element?
Is it polonium? Polonium?
Sure. Third period, go down to the third period.
Oh, third. Oh, my bad.
So what is it? Sulfur. That's right. So it's third period, and what we pay attention to is that 16, right? Group 16. Okay. So we know that that's sulfur. So how many protons does sulfur have?
Hmm?
Okay. How many electrons does sulfur have? What is its mass number? 32. Okay. And then how many neutrons does it have?
Oh my God.
Did you just wake up? Okay. Okay. Okay, so these are the most commonly used elements. So you should have a good understanding of these elements. Again, I'm not going to make you memorize them. You're going to start learning them naturally because you're going to be using them so frequently, right? So this is just showing you where they're located at. Questions? No questions? Yes.
So we have our lab due Friday.
Yeah.
The energy and matter and.
You guys didn't finish it, right?
Yes.
It's okay. Yeah.
That's all right. Just
Yeah.
turn it in like
No,
that?
no. So what we're going to do is we're going to give you an opportunity to finish it on Monday.
Monday.
Okay, yeah,
Okay,
on
so-
Monday. So what I'll do, I'll put a delay on it, so I'll push it back so you guys will have the opportunity. Yes, so your exam is not going to be due this week. It's going to be due next Wednesday, right? Due next Wednesday. So I know that the TAs are planning to have a couple of other review sessions. I will have a review session during cocktail hour. It's over Zoom.
Okay, awesome.
And then on my schedule, I may try to squeeze another one in on Monday.
Like, let us know how the test is going.
Well, you have a practice test, so you know how the test is going to go down.
Where is that at?
It's actually posted on Canvas. You'll have as many, you have 88 attempts to do the exam.
So I was looking on active or the.
No, it's on Canvas. So you're gonna look on Canvas. Okay, any other questions? Let's see, I have a couple on. No other questions? Okay, perfect. Anybody want to give me $3 million?
Want to give us $3 million?
And give you $1 from the one time.
So it says, when is the actual test after the practice test? So the actual test is due, I believe it's Wednesday at 11:59 PM. So it needs to be completed by 11:59 PM. Your practice test, oh, you paid his money. Good man, you know, the person who paid your debt, yeah. Okay. Your practice test will end 2 hours before it's timed for 2 hours roughly. So you have 2 hours to do the exam. It should be more than enough time to do the exam. Should be. But, you know, sometimes we get caught in those tail spins and, you know, we overthink and all that stuff. So I gave you enough time that you have to do your tail spin, right? And then also work your way through the exam. Okay?
Are we allowed to have like a?
No, you can't have a cheat sheet. You can have your periodic table,
Yes.
that packet. You can use that packet, yes. The
The
packet that has-
The formulas that I cannot have like on the back of my mind.
No, they should be in the top of your mind, but if you actually look in your packet, you have quite a bit of those formulas that you don't think. you have in the
So
top.
that is our cheat sheet.
Exactly. Any other questions? Yes.
I need help.
You need help with, what do you need help with? Okay, well, if there are no other questions, I'm gonna let you guys go.